As we continue kind of our refresh on applied statistics, before we go into some more research methods, we're going to look at variable associations in this case. So an association is just a relationship between two variables. If we have variable x1 and variable x2, and we know that if we put them together, x1 and x2, there's some, if we collect a bunch of data, we can see, oh, there seems to be some kind of relationship between these two variables. Whereas if we had something like this, x1 and x2, and the data were just kind of all over the place, we might assume, well, there's not really any meaningful relationship between these. We can't effectively predict what x1 or what x2 is going to be by x1 or vice versa. So in this case, we would say there's very little association between these two variables. Now, associations can be of many different types. Most of the time, we either talk about linear or nonlinear relationships, and most of the time we are going to see linear relationships. And of course, if we see a nonlinear relationship of a certain class, maybe we see something like this. Well, if we see this kind of relationship, we can just take the log of the x-axis, x1 variable in this case, and then we're going to get a linear relationship because we have an exponential kind of relationship here. So we can convert non-linear relationships into linear relationships if we want to, and that can make our analysis easier. So with that in mind, here we have a positive linear relationship. In this case, if we just label these axes for the sake of discussion, we'll call them x1 and x2 as our two variable names. Well, x1, as x1 increases, so does x2. So we call this a positive linear relationship. This is a negative linear relationship, meaning as x1 goes up, x2 goes down. And then here we have sort of a curvilinear relationship, meaning that, we certainly could, using statistical tools, draw this line, but it wouldn't necessarily be a very good fit because we'd have these great distances in a couple places where the line does not quite match the true nature of the relationship. So we're going to call this a curvilinear relationship because we've got this curve, meaning that as x1 increases, x2 sort of stays the same, and then all of a sudden it increases quickly, and then it kind of reaches a steady state and goes off to the top there. So these are some examples of different relationships that we can see, or variable associations.